All right, example 7. We're still in the optimization chapter for another day. So today and tomorrow, and then we're done with optimization. A Norman window has the shape of a rectangle surmounted by a semicircle. Somewhere around here. There it is. Tapinapio pops in there. All right. Rectangle with a semicircle on top. You've probably seen this in some houses. In fact, I'm looking across the street. I see one right now. Over there. Miles' old house over there.
Oh, I see it.
Just beyond the satellite dish. Norman window.
Oh.
All right. Anyway, if you missed it, I'll show you later. All right. Anyway, the perimeter of the window is 50 feet. So perimeter meaning not this segment, but everything else. So down, across, up, and around is 50 feet. And we want the dimensions so the greatest possible amount of light is emitted. So what do you think we're trying to optimize here? The area. Very good. Area. So if the area is the biggest it can be, the most light can go through it, right? So what I am going to do here is I'm going to put a radius on there, and let's just call that R to give it a name. If the radius of the semicircle is R, how long is this piece down the bottom?
2R.
2R, very good. R to the right, R to the left is 2R across. There's nothing telling me that this has to be the same as that because it does say a rectangle surmounted by a semicircle, right? So I'm going to call that H. And we want to limit the number of variables, but there's no way I can make this relate to that, so I have to use different variables for that. And if we remember Algebra 1, the perimeter of half a circle is just pi times the radius, so pi r. And what they've done for us is what they set in stone is the perimeter of this thing. So the sum of all 4 of these outside edges is 50 feet. So if I were to write an equation representing that, there's 2 h's, a 2r, and a pi r all together. That should make the total perimeter of 50 feet. So 2h plus 2r plus pi r equals 50. And what I use that for again is to get a single variable in terms of everything else, right? Is it easier to get h or r in this case? H. There's only one h, there's 2 r's. So it's easier to get h equals. So I'm going to move everything to the right that's not h. So 2h is equal to 50 minus 2r minus pi r. Divide everything by 2, we're going to get h is equal to 25 minus r minus pi over 2r. So again, the perimeter being 50 allows me to get h in terms of r. So now, instead of having 2 variables for this picture, I actually only have 1 variable. I have r, and then what h equals in terms of r. All right. Now, if I wanted to create an area formula for this thing, I have the rectangle area is the length times the width. That'd be 2rh. And the semicircle is going to be 1/2 pi r squared. I don't mind making the area formula with both r and h, but then I want to make a substitution, changing h in terms of its r expression, right? So my area formula ends up becoming a is equal to 2r times that h, which is 25 minus r minus pi over 2r, plus 1/2 pi r squared. If I distribute the 2r through, I'm going to get 50r minus 2r squared plus pi r squared, or sorry, minus pi r squared, plus 1/2 pi r squared. And finally, I think what I would probably do at this point is I'm going to go ahead and get a decimal approximation. We use the pi button, but then I'm going to go round to 4 decimal places. Just makes for the easier problem, because everything there is r squared, right? If I can make those pi's into numbers, I'm just going to have a single number, r squared. It's be an easier looking function. So let's do that. We'll get rid of our trig stuff from earlier. All right, so I'm going to do -2 minus pi plus pi over 2. Comes out to -3.5708. So -3.5708 r squared plus 50r. we're gonna be approximating this anyway, so if we go 4 decimal places in our work, it'll be a pretty accurate approximation, and that'll be a lot easier to differentiate. All right, so I'm at the point in this problem where I usually get to where I've got what I'm trying to optimize. I'm trying to optimize area, what I'm trying to optimize in terms of a single variable. Okay, and I use the set in stone value to establish that single variable equation, right? Once I get to this point, now it's do the calculus derivative, find the critical numbers. Looking at the R and H values, and what we're focusing on really is R. R cannot equal 0, right? Otherwise we don't have a window. So I know that 0 to infinity are my restrictions on R. And actually it's less than that, because if R equaled 50, I run out of perimeter, don't I? So it's probably less than that. But if I just set a low end of 0, obviously that's where we're starting at. A prime here is going to equal, let's see, 2 times that's going to be negative 7.1416 plus 50. All right, so A prime is that. If I set that equal to 0, it's going to establish the value of R that I need to make this work, hopefully. So let's see, 50 divided by 7.1416, 7.00, that's pretty nice. All right, so I just move the 50 to this side, divide. So we get R equals 7.00, is it feet? I think it was feet. Feet, yep. So if the radius is 7 feet, we're going to have an optimal area. Now it says find the dimensions of the window. So what we need for the dimension of the window are the radius, we need the rectangle dimensions also. The rectangle, semicircle. So that's the dimensions we want. So the radius is 7 feet. That means the rectangle length equals width equals. The length, of course, is going to be 14 feet, right? And as far as width is concerned, I've got to substitute 7 into this expression right here to figure out what h would equal, right? Because h is the width of the rectangle. So if I get my calculator back out and type in 50 minus 2 times 7 minus pi times 7, come out with a 14.01. And actually, the optimal one is a square. Again, we rounded, so that's why it's not perfectly a square. But the optimal normal window has a square at the bottom and then the semicircle on top. And if you ever look at a normal window, that most of them are shaped that way. So you're going to have a square with a semicircle attached to it.
What equation did you use to find the width?
What did I use to find the width?
Yeah.
Okay, so looking at this picture, the width is h, right? So once I know what r equaled, I went back there to find h.
Why'd you put 50 in?
Did I put 50?
Yeah.
Mm-hmm.
You used 2h instead of 8.
Oh, I did do 2h, didn't I? So I'm going to divide that by 2. So 7. Interesting. Let's see if that makes the right perimeter. Seems a little low to me, but I don't know, we'll see. 2, oh, hold on. We have 7 plus 7 plus 14 plus 7 times 3.14, 50. I guess that's, the square is not optimal. So that one's not optimal over there. That's got a square, right?
Yeah.
So more optimal would be an actual rectangle, but rectangle where this is double that and the height is the same as the radius, I think would be optimal for best area, but